So, okay, terima kasih Dr. Shakti. Okay, thank you so much.
Shakti saja.
Okay.
Inje saja.
Okay, J Shakti. Okay, thank you so much. Okay.
Okay.
Good afternoon and assalamu alaikum, everyone. Okay. So basically, so I was invited to give a talk on the floating photovoltaic generation. So Mr. Shakti has introduced me, but I want to again introduce myself. My name is actually Syed Zahurul. So I am from the faculty of the electrical and electronic engineering. Okay. So today, basically, it is a talk, but my I have thought that actually I want to make it like a discussion session, okay, because a lot of people are currently they know about solar energy, they know about the photovoltaic generation, especially in Malaysia. Okay, people actually are aware about it. But today's topic is actually a bit more interesting. This actually on the photovoltaic, the floating photovoltaic generation. Okay, we call it FPV. We call it FPV. Okay, let's start. So this is actually just a brief content. Okay, this is a brief content of today's or discussion session. So the time actually when I was doing, I was preparing my slides. So I think Fiki. So actually, much when I will start. So should I start with the floating PV something, because we know that we are in the pandemic situation. So people are stuck at house, working from home. So I wanted to, then I thought that, okay, let's start my presentation with something positive. Okay, something that the people are actually, the engineers and the peoples, they are actually trying to support our society. So then I thought to start that some nice project that have been recently implemented, actually have been implementing in Bangladesh, which are on the solar. By the way, actually, anyone, you can interrupt me if you have any question. The time I'm giving about
sorry, doctor, I'm not listening. Actually, your sound is very slow.
Oh, okay. Can you hear now? Is it clear now?
Can hear, but feel like little bit far. This is not like clear.
I think.
Okay, thank you.
Okay, welcome. So how is it now? Is the sound clear? Is it clear now?
I think okay. But I'm not sure about the Muhammad. Is it okay, Muhammad?
Yeah, okay, Mr. Muhammad.
Maybe you need to increase your sound. I think everyone here.
I already full. Sorry, I think I use the earphone. Wait.
Okay.
Okay. I should have actually sepatutnya I kena tanya at the beginning macam mana I punya sound. I hope others are fine.
Yeah, doctor, clear.
Yeah, okay. Oh, nice. Okay, terima kasih. Okay, thank you for your feedback. So, Mr. Muhammad, okay? Okay, Mr. Muhammad.
Okay, boleh cuba cakap.
Okay.
Okay, clear.
Okay.
Can. Very clear. Thank you very much. Okay. Okay, continue. Sorry.
No, it's okay, no problem. So anyone, if you have any question, so you can actually interrupt me. No, you can ask me. You boleh tanya soalan saya. Sorry, actually, I will mix the I punya session. I and maaf actually at the beginning, sebab my bahasa is not very very good. So, but I cuba cakapin bahasa lah, so that is understandable to all of us. So anyway, so let's actually start with some case study with some of the solar project in Bangladesh. Okay, some of you might have heard about the Gramin Shakti. Okay, the Gramin Shakti is actually developed by the Nobel winner Professor Dr. Yunus. Okay, some of you might have heard about him, who is actually the Nobel winner for the microcredit, okay, microeconomics. So this Gramin Shakti, actually, they basically implement the solar small standalone system in Bangladesh. Okay, in the remote areas where there is no electricity, where there's no electricity means it's not grid connected. Okay. So this is another project. It is not from the Gramin Shakti, it's a different NGO. So this actually, it is a solar floating school. Okay, a solar floating school. So maksudnya in Bangladesh, masa rainy season, so lot of places affected by the flood because the river water actually go up. So memang the villages and they actually get affected lah. So usually 3 to 4 months, 3 sampai 4 bulan lah macam tu, lebih kurang. So memang sekolah semua tu colleges so usually memang tutup. So sekolah maksudnya the primary school kita panggil lah, primary school. So education means that 3 to 4 months last time there's no education. Sebab school memang either flooded atau the villages are flooded, so dia orang susah. So what the concept came, so they wanted to actually start with like this, the floating school. Okay, the floating basic school. This school, we can see that okay, we call it the Chalon Bill. Chalon is actually name of a place, and Bill actually is a lake. It's macam Tasik lah. So it's a very big. It's as it will like I'm not sure, around like 10 to 15 square kilometer. Okay, so these places, these Chalonville places, will be flooded only 3 to 4 months during the rainy season. The other time it will be dried. So so what happens? So during this time, this NGO, they help the children to learn the computers. This computer, of course, is powered by the solar. Okay, this is the daytime activity. But during the nighttime activity, so they basically call the adults. Okay, they invite the adults to come and to learn about the farming. And not only that, they also educate the adults about the climate change and what are the actually safety, the health concerns they should take. So these actually the activities they are doing. This is this one, the peer-to-peer solar energy trading. This is the recent project. It's a very recent project. It's a very nice concept that is the one of the NGO that has started. This basically project, this is SOL Bazaar, they call it. It is it's a software developed by the PhD student and from one of the European countries. Sorry, I cannot recall. So they basically work together with this NGO and they develop this software. so they can, so that the community they can share their electricity among themselves. So share their excess electricity. So if contoh kalau satu rumah dia pasang 1 kilowatt tapi dia guna 500 watt, so yang excess 500 watt dia boleh apa export to, dia boleh apa share dengan dia punya neighbor who don't have the solar. Sebab in certain kampung not everyone can afford to install the PV. So this actually dia punya concept lah. So let's watch a video on this. I actually just printed the link, so which you can. I'm not sure whether you can hear the sound. I think cannot. But there's a subtitle there.
Dr. Syed, no sound.
Actually, okay, if I want to make sound, how about it? Can?
All right, nice. Okay.
Can you hear?
Can.
So,
Syed, if you have slide also, you can show to us also can.
oh, okay.
বাংলাদেশে প্রায় প্রতিদিন 6 লাখ কিলোওয়াট আওয়ার এনার্জি নষ্ট হচ্ছে, অপচয় হচ্ছে। অন্যদিকে প্রায় 53 লক্ষ সোলার হোম সিস্টেম ইনস্টল করা আছে সারা বাংলাদেশে। অথচ 53 লক্ষ সোলার হোম সিস্টেমের যে এনার্জি সেটা পুরোটাও ব্যবহার করা যাচ্ছে না। আমাদের যে আইডিয়াটা সেটা হলো আমরা পিয়ার টু পিয়ার ট্রেডিং প্ল্যাটফর্ম তৈরি করি, অর্থাৎ একটা গ্রামে যদি কিছু সংখ্যক বাড়ি থাকে যারা সোলার হোম সিস্টেম কেনার সামর্থ্য রাখে, তারা সেটা কিনবে, এবং যারা যাদের সেই সামর্থ্যটা নেই তারা যেন এনার্জি কিনে নিতে পারে, সেটাই এই ট্রেডিং প্ল্যাটফর্মটা ইনশিওর করে। আমরা একজনের সাথে আরেকজনের বিদ্যুৎ শেয়ারিং এর জন্য আমরা কাস্টমার ঘরে বক্স লাগিয়ে দিচ্ছি। তারা নিজেদের চাহিদা অনুযায়ী ইচ্ছা করলে টাকা হলে তারা কিনতে পারতেছে। যদি তাদের ব্যাটারিতে বেশি পরিমাণে এনার্জি থাকে তাহলে তারা আরেকজনের কাছে সেল করতে পারবে। 10 টাকা থেকে শুরু করে সে যত টাকা করতে চায় সে ইচ্ছাগুলো করতে পারবে। সুবিধা আছে, করতে যাবেন না, ঘরে কেন খরচ করে চালাই নিলাম, একটা সুবিধা আছে। আমার বিদ্যুৎ হলে আমাদের এলাকাকে যে কোনো জায়গায় যে বিদ্যুতের সহযোগিতা পায় তাহলে অধিকটাই উন্নত হবে।
Okay, I can share the link, the video link in the chat box. Better you can watch it. Oh. So the concept is sorry, so that if someone that has an excess solar energies, some excess energy, so he can actually sell to his neighbor. So that's actually concept. Then, okay, in Bangladesh, basically, there is no crisis of the drinking water. Basically, there's no crisis of drinking water. But but there are some coastal area in Bangladesh that where there is a scarcity of the pure drinking water because it is near to the sea, and the groundwater is also salty. So even the groundwater is also salty. So in that particular region, actually suffer from this crisis, the drinking water crisis. Okay. So a lot of people actually, a lot of NGOs, especially projects actually going on. So one of the concept actually desalination. Okay, this is actually one of my friends from Japan. So he is actually involved in that, and many times he visited Bangladesh, to conduct the project. So the idea they use is a thermal, the phase change process. Okay, very simple process, very common process that you can see. Just the vapor, the water, and the collected. Okay, so this is the actually place that what we have to say. This is the actually place. The place
Sorry,
is.
doctor. Can
Yeah.
you share your screen? We couldn't see your screen.
Is it?
Yeah.
Oh, why it's become? Okay, so how is it now? Ken?
Okay, now can.
Oh, okay. Thank you so much.
Can you reverse back the one slide before this?
Is it this one or this one?
Next one.
Next one, right?
Okay, yes.
Yeah. Okay. Thank you. So this actually we're talking about that the scarcity of the pure drinking water in some certain coastal area, not all the coastal area, in some coastal area that we are saying. So for purifying the water, so we use the desalination process. Okay, so this is actually our country map, and this is the region. Okay, the area, only this, not this part. This part is fine, but I don't know why this part. Actually, sorry. This is the area that actually people are affected. So we can actually see this one. We can see the pictures, and even actually I was checking from the Google map. You can see my things. So this is the area. The name of the area is a Bashanti, Banishanta. Sorry, Banishanta place. So if we can see, this is the area. Okay. And if we go to the picture, so you can see, you can imagine maybe a little bit. So these people are very poor, and they stay in a very remote place. So the main occupation is the harvest honey from the forest, because this is the next nearby is a forest there. We call it the Shundaban, the name of the forest. So that is their main occupation. They collect honey and they sell it. The honey from this forest is a very famous. It's a very famous honey all over our country. So that is their occupation. So we can actually see some other pictures like this kind of picture we can see. So these people are actually. It is between the border between the Bangladesh and India. So the border is very nearby. So we can actually imagine how their difficult situation, especially for the drinking water. So there is actually enough sources of the water, tapi and there's no drinking water. No? That's the crisis. So what the project actually is going on. So they use actually triangular solar steel cell. Okay, solar steel, we call it TRSS. That's actually remove the sol icons from the seawater and produce the distilled water. Just now that we saw the river, just now actually it is connected to the sea. So the river water is also salty. It's a very salty. It's a cannot drink. So macam tu lah. So the process, as I say, this is evaporation. Okay, it is due to the solar irradiation, so the water evaporate and it is collected as a distilled water. So this is actually from my Japanese friend, okay, Dr. Hiroaki. Okay, he is actually working on this project. So he developed this simple, very simple and very cheap, very cost-effective system for the harvesting the drinking water. It's the JICA project in Bangladesh. He's working in JICA also. So the efficiency is actually very low. Okay, this efficiency is very low, but it's still it is effective because at least they can harvest they can get the pure drinking water. That's actually the objective. So maxi efficiency is 26.2%, and they can per hour they can harvest 150 milliliter from one, like this, from one. It's very easy to carry also. Again, the cost, as I said, is very cheap. It's only 20 cents, more or less, like this, because they use the bamboo. This is one of the recent project in the same area. Okay, there's another NGO which is called BEDS, BEDS, the Bangladesh Environment and Development Society. They are working the Korean Green Foundation, and they developed an eco village project over there. Okay, so as I say that the main at this moment the problem is the drinking water. Then only you can go for other electrifying their other appliances. So this is the name. It's the name of the place that just now tadi saya tunjuk dalam Google Map. So this NGO dia ada tiga komponen dalam project, which we call it the green housing, the green education, dan green business. Okay, so there are some 4,500, almost like 4,600 people. Actually, they are getting the safe drinking water, the 12,000 liters per day. So that's actually produced very effective the project. So they have developed macam system like this lah. They call it the water ATM. So kita ambil duit kan, the ATM. So they ambil actually water because they have the scarcity of the water. So more about this, kalau anyone interested, you boleh visit dia punya website. They call it betsbd.org/home. Okay, so they have some the detail lah, macam mana they are helping the students and for the education. At the same time, actually, they are actually educating the adults, especially the women. Okay, regarding the mangrove, how they should regarding, I mean, the awareness. They're creating the awareness on the saving the mangrove. Okay, because mangrove is the one that they are actually, we know that the seas that the coastal area are saving. It's very important for ecology, the mangrove ecology. Okay, so that's actually some of the successful projects that I discussed. In my next session actually will be on the solar energy, the water status, the energy assessment. But before that, if there is any questions, or maybe should I continue or wait for the question, Dr. Mubarak? What do you think?
It's okay, Dr. Syed. You can proceed.
Can proceed, okay. So you can see my slide, right?
Yes, Doctor. Can.
So our next status is the world energy, the solar energy world status. That this is actually at a glance. At a glance that the status of the solar energy that increased 12% in 2009 to a record of 115 gigawatts, okay, all over the world. This is the data is from the REN 21, renewable energy report. Every year they publish their report. Okay, they collect data from all over the country. Then from January to October, then the capacity is was like 15% higher than the same period of the last year. Okay, so which actually is a new record in 2020. So the renewable capacity is actually higher. Then our modern renewable energy is accounted for the 11%, okay, of the total energy. The total final energy consumption, okay, in 2018, and it was 9.6% in 2013. And even though it's actually really growing trend, but it still is actually, it is meeting 1/3 of the demand. Okay, the renewable energy is meeting 1/3 of the demand growth. This is very interesting, and it's very actually very interesting actually, the graph that we can see the evolution of the PV cost, because this data actually, this graph actually shows the cost of the PV from 1970 to until 2020. Okay, this is the graph is it's taken from International Energy Agency. So we can see that in 2020, you can see that in 2020, the cost, the per watt, is actually has come down for monocrystalline PV has come down to 0.2 USD. Okay, so around this cost. So it means that 0.2 USD, if we convert it to a ringgit, it will be like around 0.2 times 4.5, so 90, right? So that means yeah, 90 cents, around like this, okay, more or less, per watt. Okay, so this is the cost of the PV. So it's a really it's a promising. It's a really fantastic how the price actually has gone down. Okay, but one thing I want to mention here, let's say if you want to install 1 kilowatt NEM, net energy metering, if you want to sorry, anything?
Doctor, do you have the latest number for 2019 or 2020?
The number of what?
Of the cost now is 0.2 of USD per watt, 2015.
Yeah. Actually, this is the one they are saying that this is actually until 2020.
Oh, okay.
There's the one that's saying. So 0.2 will cost around like 90 cents per watt. It will be more or less, if let's say if it is 2015, but I think more or less it's the same. But let's say if you want to install the NEM in your house, it's a 1 kilowatt. And if you contact the company to install for you, so they will charge you like 4,000 to 5,000, including everything, including the net energy metering, including PV cabling installation, semua, the permission, the repair, the TNB, all of this. Okay, so if it is 4,000 to 5,000, that means still per watt is coming like 4 ringgit to 5 ringgit per watt.
The 4,000 is how many watt?
Usually, actually, I asked the company. They say it's for 1,000 watts. Around like this, because it includes everything. It includes inverter, includes NEM meter, and the approval, the installation, cabling, everything is together.
You mean 4,000 ringgit or 4,000 US dollar?
For the ringgit, 4,000 to 5,000 around this.
So one house require normally how many kilowatt?
Well, this is depends on your this is of your appliances, depends on your load. Okay, it depends.
Average?
So usually 1 to 2 kilowatt like this.
Oh.
Usually like this. This is small for the small houses. So we this is the RE share, the renewable energy share of the total final energy consumption. Okay, this data is also up to 2018. This is the latest data that we can get. Okay, so we still can see that almost like 80% is still from the fossil fuel. Okay, the nuclear energy, yes, is still is a good, it's 2.2. But the renewable we have, so we can see the wind biomass is 2.1. Hydro is actually 3.6, quite high. But now we can see, if we go on the list, we can see the next one. So the solar is actually is increasing. Okay, even though the wind power is 5.9%, where the solar is 2.8%. Okay, but it's still actually, if we check here, okay, the solar actually is these days, actually these years, 2018, 19, 20, these are actually the in increasing trend. So, but we can see that in terms of investment in renewable energy. Okay, so the China, EU, India, and the US, they have become the cheaper to build the wind or the solar PV than to operate the coal-fired power plants. So that's actually is a very interesting result that we can see, the things that happen, that now the renewable energy actually is getting cheaper, okay, compared to the coal-fired power plants in terms of their operating cost and also the maintenance and other things. Okay. Then so there's a top 5 countries, okay, in 2019. So you can see that China has occupied, or that's a top 1 for solar, okay. Then also wind, hydro. No, hydro is a Brazil. So the first 3. Then we can see the solar. Also, solar capacity is the United States, the second one. Then India also is take the 3rd position. So what is actually the significant thing here? That the China and the other developing country, so they have actually emerging economics, okay, to install all this actually the renewable power plants compared to the developed countries. If we consider the cumulative RE capacity, so China, they have in 2019, the China, they install 780 gigawatt, okay, PV, renewable energy total. Okay, US to the second position, 282. Brazil is 144, sorry, and India 137. Germany has 124 gigawatt. The where is in Malaysia, they're saying that actually REN is saying that 0.6 gigawatt, but actual scenario is actually a more higher than that. Later we will see for the Malaysia section. So in 2019, more than 200 gigawatts of renewable energy actually is added. Okay, whether it's actually very promising, very fantastic. And so together with this, the raising the global total, the renewable energy will be 2,500, almost like 2,600 gigawatt, maybe actually more than that. Basically, the data is actually every day is changing, because every day new not even every day, maybe every week or maybe every month, so new generations are actually adding to the world. So the data actually is changing, is changing every time. But this is up to 2019, the data. So you can see that the solar is 115 that we say. Next is our the renewable energy status in Malaysia. Okay, we have to see the when we study how is the scenario in Malaysia. Since 2001, the Malaysia actually is devoted for the renewable energy. Okay, because Malaysia is want to be one of the low carbon emission countries. Okay, and also want to achieve the 20% of the renewable energy by 2025. So that is actually the target. So Malaysia is actually in line with the target because the very good incentives and the grants and the encouragements efforts from the government and also the support to the R&D activities. So you can say that the Malaysia government has the expenditure from the government for the R&D from the government R&D is increased from 6,071 million to 15,058 million from 2008 to 2015. So this is the scenario. Okay, in 2019. The peak electricity demand is increased by 1.2%, which is 18,566 megawatt, okay, in Peninsula, and in Sabah is 1,001 megawatt. At this moment, 21 large-scale solar farms, which call it LSS, okay, are in operation. In 2019, 12 LSS were added. Okay. Pengaran Power in Johor, 200 megawatt, and another one, Jimah East Power in Negeri Sembilan, so 2,000 megawatt. This report is from the Suruhanjaya Tenaga. So there's other fantastic data, okay, which is that what they're saying that 179 megawatt in 2008 to 725 megawatt in 2019. Okay, so it's actually helping the national goal to make the renewable energy 20% of the capacity mix by 2025 and becoming a low carbon economy. According to SEDA, the NEM, or also we call it feed-in tariff or net energy metering. So this is 500 and almost like 600, okay, megawatt. The capacity is installed so far in commercial operation. And we can see that from the fossil fuel generation in 2020, actually is 82%, okay, decline from, but in 2030, they expected to have 70%. Also, smart meter also installed all over the country. This is, we know that the smart meter also the part of the smart grid system. So this is also actually is is in line with the renewable energy integration. There is some successful increase in renewable energy deployment in Malaysia, particularly in the PV. Yes, so we have already seen that mainly in Malaysia is actually is a very potential for the PV compared to wind, and also the biomass. Later we see that also the biomass also we can see here, hydro maybe mainly in Sarawak and also somewhere in Perak that we have seen there's some small scale hydro there, the hydropower plant. Biogas is also improving. Okay, you can see that the biogas in 2017, this is the energy is from biogas. But among all of this, the topmost is the solar. And with this one has become possible because it's a massive support from the government. At the same time, the people are also actually aware about the greenhouse gas emission. So the people are interested to install the anyway in their house, or sometimes in the industry. So this is the way actually cumulative carbon dioxide avoidance is increasing. Okay, and some of the projection. This is the recent data from SEDA. Okay, so we can see actually what is the status of Malaysia. So solar PV and up to total. Actually, total is 1,727 gigawatt hour. Actually, this is actually energy. Okay, this actually energy is hour. We consider as actually hour. Then biomass also 1,465, biogas 692, small hydro 417. So this is the portion also together is 100%. So among all of this, you can see the solar is the highest. The second topmost the biomass, then biogas, and then small hydro. Now we want to see actually now we want to know discuss about the floating PV. Which is our main question today. The first of all, actually, why we are thinking about the floating PV, or we call it FPV. In everywhere, actually, around this world, actually, there is a lot of unused the water surface. Okay, so we want to use the unused water surface. Number one. Number two is that we can see that actually it's many countries, even in Japan also. So we have realized that we are destroying our forest, we are altering our forest by the PV. So it means that we are destroying our forest, and in that place we are installing the PV. So this is actually not, it's not a good solution. Because our PV, the main objective of the PV or installing PV is to the greenhouse gas emission. But on the other hand, we are actually destroying the forest. So it's a mutually exclusive problem. Okay. To solve the problem is one of the solution is NEM, which is the rooftop-based PV. The second solution is actually the floating PV. So we can use the water surface, and it has actually a lot of advantage if we can install the PV on the water surface. So what is the advantages? So that the efficiency of the PV can be increased because of the cooling effect of from the aquatic environment. Then low maintenance cost, because why? Because if we have a grounded PV, this is a lot of soiling, or you call it dust, can accumulate on the PV surface. So that's what actually will cause the PV to, the less production. But if we install on the water surface, so the dust accumulation will be, of course, less. Okay, so this is actually the positive, so the low maintenance. Installation, in terms of installation cost on the land, okay, is also for FPV is that would be the less. Okay, that one actually what we can see. So the major the floating components, okay, some major floating components. This is actually our floating components. You can see the main floating body, then the islay and supporting leg, the fastener part. So these are actually main components for building the floating, okay, the floating PV. So we can watch one video. Maybe I can share with you in the chat box. Okay, the sun time we can watch here. My sound, actually I should have brought my, so this is the video on actually how it is formed. Okay, you can get this actually. This material, these components, this materials actually are easily available. You can get, I think, Shopee. I'm not sure, but Alibaba, yes, can get Alibaba, and it's a quite cheap. It's a quite reasonable, the price. So what is the opportunities in Malaysia? FPV. Okay, we know that many countries has developed this. So Japan is the first country that who has developed the FPV. Okay, then China, France, Indonesia, even Singapore. Even Singapore, they have also implemented. They have developed one FPV. I watched one YouTube. In Malaysia, yeah, it's just a land the scarcity is the issue, because in Malaysia mostly it's a lot of forest. So it's not a wise idea to alter the forest. Okay, to alter the forest.
Doctor,
Yes.
Doctor,
Yes.
one question, sir.
Yes.
What is the impact to the ecosystem of the lake if you use this?
It will come. It will come. I will discuss, Doctor.
Oh.
I will discuss. It will
Okay.
come about the ecosystem. Yes. Actually, it's a very good question. Very good question. So in Malaysia, has of course it's water areas, okay, which can be used, okay, for especially for this one for FPV, okay, and for example in Selangor that we have actually seen that I have found that has almost more than 50 lakes in Selangor itself. So many of them are not utilized, okay, transferred into opportunity. So we can transfer it for the harvesting or installing the solar energy. This is the largest floating PV in Malaysia. Okay. The Solar West Holdings Berhad, they have installed a 13 megawatt peak, a large scale solar, okay, FPV. The location is in Dengkel, and it can power up almost like 5,800 houses, and also can offset and can cut down annually the 11,548 tons of carbon footprint. This one, there is another one. FPV was developed, which is in 2015 in Malaysia. They call Labus. They call it the place of Labus FPV. Okay, location also in Sepang is 108 kilowatt peak. Okay, around like 432 panels. Okay, so it's operational since that time, and it's a grid connected. So most probably this is the first FPV in Malaysia in a commercial way. So FPV, now we see what about the other countries? Okay, other countries is they in Bangkok, okay, Thailand. So they are also in operation, 45 megawatt FPV. But nice thing is it's actually a hybrid system. Okay, it is a hybrid system. And that means that it's a hydro. So this actually dam for the hydro. So part of it actually installed they are actually installing the PV. It's another very nice concept. The world largest is as usual in China, because China actually is in topmost in everything. For the last consecutive years, you can see that the capacity is a 70 megawatt. It's complete in 2018. Okay. And it's powering almost like 21,000 households. This one is in Japan. They built it in 2012. Okay, it's also powering almost like 22,000 households. It's also 70 megawatt. Okay, this is in Kagoshima. And last time I got an opportunity to visit this place when I went to Kagoshima. It's the southern part of Japan. It's very fantastic, very organized, and that is actually a winter time. So you can see the solar irradiance. I cannot read Japanese, but I can understand from the unit that this is solar irradiance, 84 only watt per meter square. The expected one is normally the bright it's a bright day. It should be 1,000 watt per meter square. But since it's during the winter time, it's a very cloudy, foggy. The temperature also 11.2 degrees Celsius. So you can see the production only 4.3 megawatt. It's totally cloudy. I mean, no sunlight. I can see the 84 is actually almost like zero. So this one is their data center, and they open to the visitor. So the visitors can go and can see where's the production and how it is built. This is interesting. Now the challenges in FPV. So we are coming to your question, Doctor, who will ask me about the FPV. Okay. So the first challenge is, let's say, if we want to actually develop the FPV in the typhoon-prone regions. For example, it's in the Philippines. There is a place in the Philippines, they hit 20 storms per year. Okay, so then what we'll do? How we can how our PV can tolerate this kind of rough climate? So we can watch a video again. I want to share with. Sorry, I need to stop the sharing. So this one is in Philippines. So they are actually doing the testing. So this is one of the challenge. This is one of the challenges. Okay. I have shared the link with you. You can watch it at your place. So you can see actually how difficult. So if this kind of process. The second issue is the environmental issue that just now I was asked. Sorry, I do not know the name. So anyway, so first of all, actually about the fishing, okay, the fishing activities. Because if you occupy full of your leg, so how you are going to catch the fish? So you need to find, you need to find some, you need to, find, you need to do the research on that. So maybe on the designing process, okay, you can see that actually there is a design that on that actually how it could be scattered so that the fishing activity is not hampered. Otherwise, the fishermen will be they will be in a difficult situation. So we want to do something good to the society. So we have to find a solution. We don't want to disturb the natural system. And the second is the marine economy. Actually, there are some researchers that have already done, and they have found that actually there is there's no harm to the marine life, to the marine ecology, the system. But to me, what I have actually seen, I think the more research should be done on that. Okay, especially on the, I think I have not added this picture. Yes, because I have seen that there is a one place. I have not added this picture. I have seen that there's a one place. What they have done is they take a solar. Okay, this is a solar. It's a floating solar. Then after that, under the solar, they are actually cultivating the seaweed. They want to check actually how is the growth, and not only growth, also the nutrition factor. Is it the changes or is the remain same? Maybe the seaweed can grow, but the nutrition could be different than the normal one. So they are actually still, the people are still doing research on that. Okay. So that's why actually I'm saying that the more research should be done on that. Another challenge is the cost. Okay, the cost. The main cost of the FPV, the floating PV, is on the pontoon. Okay, so this is the base of it. So this is actually taking 50% of it. So it means that we should do more research on this platform, so that we can produce the economic, the platform for the floating PV. Because if it is cheaper, the cost of the installation cost will become more cheaper. And another research actually also people are doing, which is the tracking system, the solar tracking system. We know about it, that the solar tracking system. It means that the PV will move with the position of the sun. Since it's on the water, so it can actually rotate. It is possible to to rotate it. So this also the researchers are working on that. The next I want to share about the FPV research, which is actually conducted at UTHM. That this is one of our researchers. Okay, that the student has done some initial. They took a 10-watt polycrystalline type PV. It's weight like 1.5 kg. Yeah. Okay, then he tried to float it on the water and did the data collection because he wanted to check how is the performance, electrical performance we call, because we need to check actually the performance of it. Yeah, because we are saying that this is a cooling environment, it will be better. We are actually saying it's our assumption, but we need to prove it through our actual data. Okay, so the finding is that so the finding is actually quite the maximum power. Okay, the maximum power they have found is like 7.14 watt out of 10 watts. Is around like 70%, 72% like this. So another research actually conducted by one postgraduate student. This is a master's dissertation. So it's a simulation-based project. Okay, simulation-based project. So that one they found that an UTHM, he considered the UTHM as a platform, the case study. So he found that almost 50,000 meter square area is actually covering the water bodies, lakes. So can be installed like a 1 megawatt, okay, PV. And then at the same time, total, because he did some simulation, it will cost like around 52.3 million. And this also can reduce the carbon emission 1,241 ton per year. So he did some analysis. This is one of my students. This is actually our research team that we have recently done. The recently means it's still actually ongoing. Okay, my students still working on that. He completed the project. He submitted. So the title actually the performance comparison of the monocrystalline PV module efficiency on the grassy land and the pond floating. Okay, so we used 100 watts. Okay, 2 modules that weighed around one module around 8.5 kg. Okay, kilogram. We collected data only 5 days because of the pandemic. A lot of challenges. So around 11 to 4 p.m. like 5 to 6 hours, more or less. We conducted the experiment at the FKE lab. Okay, so in order to float this PV module, it cost around 60 ringgit. So because of this point, we used the G412, okay, as a base for at the base of the platform as a function. Okay, then we analyzed the result. I haven't shown the result here because it hasn't published yet. But we have found that the efficiency of the monocrystalline PV actually is actually increased. We have found that the efficiency of the monocrystalline PV is increased because the cell temperature actually is managed to decrease. Okay, then we compared with the grounded PV because there's two PV. One is on the grounded one and one is on the floating type. Okay, I want to show you the some other thing. This is the data logger that we implemented. Okay, this is also because two data logger. One data logger is for the floating, and another data logger is for the grounded one on the grassy land. So we also compared their output power. So that's also actually we found a significant improvement. Watch a video. This is actually unlisted video. You can watch.
Malaysia is blessed with 62.3% of tropical forest that contains the rich flora of animal species. So the alternation of it by a large solar power plant lead to the contribution of natural ecosystem. So what is actually the solution? Since it's a mutual exclusive challenge for Malaysia. So one of the best alternatives would be the floating PV system. So the system that actually we use the unused, sorry, it's the system that we install unused water, and I think that it can make an important contribution to green energy innovation.
Dan selamat sejahtera. Saya Muhammad Ali bin Muilas, pelajar kejuruteraan Penyelidik dan Penyelidik. Ini saya akan menentangkan dan memperkenalkan tentang saya punya projek, iaitu perbezaan performance bagi solar yang berada di atas darat dan juga di atas air. Ini adalah panel solar yang didiamkan di atas darat dan akan diambil bacaan, kemudian dia akan dibandingkan dengan solar yang berada di atas air. Okay, bagi gagasan pada terapung, ini panel yang akan bersentuhan dengan permukaan air, diapungkan dengan pelampung yang dimuatkan sebanyak 12 biji, dan panel ini akan dibiarkan terapung hingga bacaan data diambil hingga petang. Yang akan dipaparkan pada skrin ini adalah tarikh, jenisnya masa, voltage, current, masa, persekitaran.
This distance is very significant because we have experimented with the loading movement instead of traditional fixed platform. So in case any increase in water level due to flood between these floating point together in the system, it will float. Okay, so we appreciate the support of our research center. So yeah, give me
I think you have watched the video. So another ongoing our project is this is on the PV cooling, okay, the photovoltaic cooling. So we want to, because we want to actually crystalline silicon, because we have the characteristics that the cell if the cell temperature increases, the output power actually decreases. So this is the actually problem of the crystalline PV module. Okay, so it's the same the PV module, the 100 watt, okay, calculated for 7 days at our FKE. So the cost of the cooling will be like around 100K, just for the cooling. Sorry, around 100 ringgit. Sorry, around 100 ringgit. So this is the some of the data logger and the system. So the third ongoing project is PV cleaning. So we are in the PV cleaning system, especially for the rooftop base. So this, because we can see that we we know that if for the rooftop base PV, the problem is to clean the surface of the PV. If it is a ground base, say the grounded type, so we can actually clean it, because we can, we can use the wiper and something to clean the surface of the PV for them, for as a maintenance. But if it is a rooftop, it's actually quite difficult to climb on the roof and clean regularly. And the problem is that if we do not clean, so the efficiency of the PV, the output power of the PV, everything will go down. So that's the reason it needs actually regular cleaning. So we are actually developing an automated system, okay, to the system to clean the PV surface for the rooftop for NME application, net energy metering application. The project is still in progress, so I just have shown you the 3D diagram. Okay, this is one of my publication of our publication that we published recently, 2020. Okay, in a key one publication. This is it is actually the PV performance and the seasonal based modeling. Okay, followed by modus evaluation and the dry season energy yield prediction model. Okay, for any in Malaysian perspective. So what we have actually found that if it is a real environment, we have seen that the amorphous silicon actually yields 15.7 higher kilowatt hour than the carbon silicon. So this is actually one of our significant findings. Okay, but during the dry season. So I think I am actually almost at the end of our discussion. Okay. So the summary is that actually we have seen this is the very nice growth of the renewable all over the world, including Malaysia. Okay, the installed capacity has reached actually more than 200 gigawatt. And then the second thing is actually the people, currently especially the developing, the people from the developing country, they are aware about they are actually getting aware by this one, by the NGOs and the people regarding the reduction of the carbon dioxide and the greenhouse gas emissions. This actually is a very good point, but it's still not enough. So we need to actually move on, so that actually people are more aware about this problem, and especially the coastal area, in the rural area, these are the ones which the people should be aware about it. In Malaysia is the renewable energy capacity is really the growth is really fantastic. Okay? But Malaysia now actually can think about the floating PV, because it has a lot of unused water surface. Maybe not. Should not occupy the whole water surface. Maybe some portion of the water surface can be used. Okay, so that one actually will help to reach to the nation goal, which is the 20% of capacity mix by 2025, and also become the low carbon economy country. As a TVET, we have the responsibilities, the TVET researchers, we are engineers, we technologists, so we have the responsibilities. Okay, so responsibilities in terms of the educate the communities, and also the find the way, find the technological solution for the community people, so to improve their economic benefit, okay, to the society. So that's where actually we can contribute to the society. So that's actually this is the summary that actually I wanted to deliver. Okay, today. There's some references. There's some more references where I have not included. This is some of the references that I used. Okay. So now we can go for maybe question answer session. Actually, that's all from me.
Doctor?
Yes.
Will you be sharing the presentation?
Presentation video, is it?
No, the PowerPoint.
PowerPoint, yes, maybe some corner I can share.
Thank
Yes.
you. Okay, Doctor, I have a few questions, Doctor.
A few questions, maybe one by one. Dr. Alex, right?
Yes, yes.
Okay.
This type of floating PV is only suitable for calm water, right?
Actually, the answer is yes. Initially, the answer is yes. That because if it is a rough water, so the challenge is that whether the PV can face this, the roughness. That's actually the challenge. But at this moment, the people are doing research on that, how they can actually make it floated on the, on the rough water.
But what is the lifespan we can expect from this PV, FPV?
Usually 20 years. We know the ground type PV is 20 years. Okay, the ground. So they are also saying the same, the 20 years, 20 to 25 years.
But in terms of maintenance, it will be quite hard, right? For maintenance, this one.
Not really, actually, because they have if we can see, I think I have not shared the video, that one. They are using what is that? They are using, oh, okay, I can share you this, that I can show you here. So they are basically using this passage, this pedestrian way, so that way actually they can reach to the PV panel. And not only that, there is one video, if you just search in the solar vest or the FPV in Malaysia, then you can see that actually there is a passage there, okay, all over the places. So the technician, they can walk around and they can check. They can, if there's anything, any cleanliness or any fault issue, any crack issue, so they can go and they can find fix.
That is on the top surface. What about the bottom surface?
The bottom is actually, if you have noticed, the bottom is empty. The bottom actually is empty. It's like that. Or where is it? I think that is on the video, if I'm not mistaken. It's actually empty. So bottom. Bottom actually, it is not in touch with the water.
But it will encourage some growth. Then the cooling efficiency will go down.
Sorry, I didn't understand this.
Over time, there will be some growth, some moss growth down there. So the cooling efficiency will be affected as well.
So we want that one, that it should be cool. That one we want.
Correct, but if there is some growth, then they will not be cool.
Sorry, I didn't get growth.
Fungus growth.
Fungus growth. Fungus might be, yes, might be, but that's why we say, actually, we tell you we need the maintenance, doctor. That's why we say that we need the PV, so we need the maintenance. Even as a maintenance is like a cleaning. So since the water is not an issue there, because the water is available, right? It's on the water surface. So you can use the water to clean it regularly.
Okay.
It's a good question, actually. Dr. Alex is a good question. Dr. Alex Tan, what it says, actually, the growing of the fungus or anything, but whatever it is, actually, we need to maintain. We need to do the maintenance.
But the cost of using this FPV, because we need to connect to the national grid.
Yes.
So it will be very far away to the grid, right?
Actually, the answer is yes and also no, because you will have the cable. The cabling could be the underground cable, okay, underground cable, and it has to the inverter will be on the grounded. Okay, so inverter will be grounded. So from there you have to connect to the substation.
So there will be some moving part looking into the up and down of the water level. So how do you tackle that problem?
The moving part means,
Connections of the cables
huh?
between the floater and the
Uh-huh.
connections.
Yes.
How
No,
do we
that,
do that?
actually that one we have to. That one is the connection part. That there's a specific for the floating PV. There's a special connection for that. It's actually, even though it's a moving, but I mean there no problem in that. No, you won't be. Yeah, it's a problem. Because we can see that there's a lot of installation have already done and it's successful so far. No issue, because it's actually new. Maybe after 5 years we don't know yet. So that's why still we need to actually, we need to monitor and we need to do the analysis. Then maybe after 5-10 years, then only we can see how is the performance. That's why, as a university wise, so let's say that if we can install a small scale, let's say 1 kilowatt, okay, 1 kilowatt or maybe 2 kilowatt PV, the floating PV at the UTHM, and let's say we monitor for 5 years. How is the growth? We monitor in different perspective. That what you mentioned is very nice point. The fungus growth, or anything moving point, or maybe anything, the water level rise. Normal water level rise is actually not a problem. So because it will float, or any other new issue, maybe we don't know. And also the ecology is also an issue. So we actually all together we have to actually monitor for at least for 5 years the collected data. Then only we will see how is it.
What is the cost difference between this floating and the land farm, solar farm?
Regarding the costing, so say if we install on the ground, okay, so if it is like a plain ground, so it's easy to install. But if let's say it's a forest, has a plant, so you need to cut it, you need to make it suitable for the PV. So there's an additional cost. If it's a low ground, so you need to fill up with the soil and make it up higher. Then we need to place the stand. So the stand also actually quite expensive, because it's made of usually the aluminum stand. But but when we think about only the floating, so we only see this one, the pontoon, only the base, which is actually plastic. It's a plastic one. So it's very less, would be very less.
Can the plastic?
I didn't do actually any analysis in terms of costing, the costing on the the grounded one and also the floating one. Maybe I will consider this one.
Can the plastic last for 20 years? Pontoon.
Plastic, yes, it will last long. But of course, need a maintenance. Let's say that the screw or anything, of course, it is regular maintenance. Plastic, it will last long. So far, no problem. With the water, there's no problem.
But will it last 20 years?
Manufacturers are saying, it's a good question. They are giving warranty. So
they're giving warranty for 20 years?
No, they are not giving warranty, but they are saying that it will last on for 20 years. But manufacturers for PV, they are giving warranty for 20 years.
PV 20 years, okay, but the pontoon itself, the plastic, open for UV radiations, all those things, can it last for years?
That's actually also a question, because we cannot see any, we just started the installation, so we do not have data on that. Other than that.
Okay.
That how long the plastic will can tolerate the environment, can sustain over the environment.
What kind of plastic are they using?
They haven't mentioned about it, the watercolor plastic, but this is they call it the Fonton, and they are saying that this is the environment friendly. Okay, this only friendly will be the aquatic environment. So it's a new product, so that's why we are still actually not sure about it unless we do the long-term experiment, we install it, and we see actually how it is. But since it can actually, because each one they have, if you check in the Alibaba, so they have a different type. They have a different type, such as the type means, let's say you want to fix the tilt angle, so the legs will be different. Okay, at the same time the weight of the PV, so how heavy your PV is, how big your PV is. So based on this, you need to actually choose the PV. So like this, actually they have the few types.
Okay, that's all my question.
Okay, thank you, Dr. Alex.
Sorry.
Doctor,
Yes.
okay, there is a question in the chat box whereby it was asked by Mr. Kamarul Baharin. He asked for, has there been any research done on the matter Dr. Alex brought up? Over the course of years, how would build-up of unnecessary contaminants? Or if such build-up do happen, how significant will it impact the efficiency of PV?
There has been any research done on the matter Dr. Alice brought up. Over the course of the years, how would it build out the unnecessary contaminants? Yeah, that's why I actually said, because it's actually new, compared to new, because Japan, at Kagoshima that they have built it is actually different. This is on the seabed, but they didn't make it like a totally floating the way it currently is going on, like on the plastic one. It's not like that. The Japanese is a seabed. It's like a ground. It's like a plain ground. But they build on the sea. So that's actually different. But the current technology that they're using, so we need to actually see. We need to get the real data. Then only we can see actually what is the benefits, what is the constraints actually, what are the problems we'll be facing. So it's a new thing that we have started, okay, all over the world. So we need to actually spend some more time.